Hi, under rotation, here's a recap of what we've done so far. If we rotate triangle ABC about the center 0, 0, clockwise, here's what we have. I've mentioned already that what we need to do is to copy down how to move to A, B, and C from the center. Now from the center 0, 0, if I have to move to A, I might decide to move 1 unit to the right and 3 units upwards. So I'm going to write 1 unit to the right, 3 units upwards. That's for A. For B, if you follow through from the center, 1 to the right, 1 upwards, 1 to the right, 1 upwards. And then for C, 1, 2, 3 to the right, 1 upwards. What I need to do is to rotate my page back and then copy this down. Now let's rotate back. If I copy that 1 to the right, 3 upwards will give us this as our new A. I will call it A prime. Our new B, 1 to the right, 1 upwards. So here is B. I'll call it B prime. Now our new C, 3 to the right, 1 upwards. Here's C prime. And all I just need to do is to join the triangle. And there is what we have. For this lesson, we are going to start by extracting the coordinates of a triangle and arranging them in matrix form. This will set the foundation for understanding how matrices help us to perform transformations like rotations efficiently. So let's get right into it by first identifying the coordinates that define our triangle and placing them into a matrix. So for A, you will see that the coordinates is -3 and 1. We might write that in a matrix as -3, 1. And then for B, we see that that's -1, 1. We might write that in the matrix as -1, 1. And for C in the same matrix as -1, 3. So this represents A, B, and C. Now after rotation, the triangle ABC have become A prime, which has a coordinate of 1, 3, B prime, which has a coordinate of 1, 1, and C prime, which has a coordinate of 3, 1. The question that we then ask ourselves is, this rotation that has made this first matrix become the second one, is it possible to represent that rotation as a matrix? And this is what we want to consider. What you see on screen are called the base vectors, and they are the vectors I and J. Now we want to consider what happens to these 2 points if we rotate them clockwise 90 degrees about the center. Why are we doing that specifically? Remember that when we did this earlier, we rotated triangle ABC about the center 90 degrees clockwise. We're going to do the same thing to these vectors. Now if we pick I and we rotate it 90 degrees clockwise about the center, we expect that I will become I prime, and we have its x coordinate to be 0 and its y coordinate to be -1. And in the same way, if we rotate J 90 degrees clockwise, we expect it to become I. So we say J prime will be at 1, 0. We may write J, I and J in a matrix as 1, 0 and 0, 1. These are I and J. After transformation, I has become 0, -1, which is what we have down here, and J has become 1, 0. We're going to pick the first triangle which is minus 3, 1, minus 1, 1, minus 1, 3, and we are going to pre-multiply it by the new matrix here, which is 0, minus 1, 1, 0. We want to show that by all indications, we should get 1, 3, 1, 1, 3, 1, which is the coordinates of this other matrix. If you want to learn more about multiplication of matrices, I already made a video on that. I will link it up now. Please click on it and consider many more examples that will help you to understand it. So we want to show if this is true. One thing you want to do is to cover the rest of these columns and just pick negative 3 and 1 and then use that to multiply. And how do we do that? You multiply 0 by negative 3 and then you add 1 multiplied by 1. That's 0 times negative 3 plus 1 times 1. Okay? And then for this row, you do minus 1 times negative 3 and then you add 0 times 1. And we are done with negative 3 and 1. What we want to do next is to pick the second column and then multiply. I'm going to cover the first column up and the last one and only deal with the second column. So again, we pick the first row and this column. So 0 times minus 1 plus 1 times 1. 0 times minus 1 plus 1 times 1. And then for the second row, minus 1 times minus 1 plus 0 times 1. And we are done with the second row. Now we pick the last row, 0 times minus 1 plus 1 times 3 and minus 1 times minus 1 plus 0 times 3. If we simplify this, we know that leaves us with 1 there. This one leaves us with 3. This one leaves us with 1. This one leaves us with 1. This leaves us with 3. And this leaves us with 1. And if we compare that to this, we will see that they're essentially the same thing. Which means that the matrix 0, minus 1, 1, 0 actually represents our rotation 90 degrees clockwise about the origin. Next, we're going to consider what the matrix 90 degrees anti-clockwise about the origin will look like. Again, we begin with the base vectors. If you remember, we have the axis, or your Cartesian plane if you like, and then we have the I vector and then the j vector. Which we can put in a matrix as 1, 0, 0, 1. And we attempt to rotate it anti-clockwise 90 degrees about 0, 0. And then we see what that will become. Anti-clockwise is this way, which means our 1, 0 will become 0, 1. And our 0, 1 after rotation will become minus 1, 0. So far we have learned that the matrix of transformation that represents a clockwise rotation 90 degrees about the origin is given as this, and for an anti-clockwise rotation 90 degrees about the origin is given as this. What if you want to find out the matrix of transformation for 180 degrees about the origin? Can you find that out? Pause this video and try it. Here is I. If you rotate it 180 degrees, it's going to go the whole way up to this point, which means it becomes minus 1, 0. And the same way, if I rotate 0, 1 about the origin 180 degrees, it will exactly become 0, minus 1. Which means that this matrix represents a rotation 180 degrees, either clockwise or anti-clockwise, about the origin. Did you get it right, and do you understand it? If there are other methods you have considered in solving this, could you let me know in the comments below? In the next video, we'll consider other examples on matrix or transformations. Join me then.